Okay guys, welcome back. So I will discuss more concepts on conservation of momentum from the videos here on. Now in the last video we talked about two masses that were moving perpendicular to each other, then colliding with each other, and then moving as a single mass. Now what happens if the velocities of these, the initial velocities of these two objects are inclined to some angle, inclined by some angle. So let's take an example. If I take this, I will take an object like this. It is 10 kilograms, right? Take the object to be 10 kilograms, right? And its velocity to be, I will take it as 8 meters per second in an angle, 8 meters per second in an angle that is 30 degrees measured downwards in the clockwise direction. So this is 30 degrees downward in the clockwise direction. Alright, and another mass of say 6 kilograms moving at take 6 meters per second, velocity goes to 6, but this angle is now 60 degrees measured counterclockwise. Now this is 6 kilograms, an object of 6 kilograms going at 6 meters per second at an angle 60 degrees measured counterclockwise and in the upper direction. Alright? So these two objects collide each other, and if these two objects go together, the mass is added, the total mass is 16 kilograms. What is the final velocity and its direction? So that's the problem. So I'll take the total mass to be 16 kilograms. Because these two objects go as a single unit, and the velocity to be v, like this, the general velocity, and an angle of theta, general angle of theta. So theta I will measure it clockwise, so sometimes theta may be negative, so it will be measured theta will be counterclockwise, so I will measure this angle theta as counterclockwise. Sometimes theta may be negative, so the theta will be clockwise if theta is negative. If theta is positive, theta will be counterclockwise. And if v is positive, it will be in this direction, and if v is negative, it will be in this direction. Alright, so what actually happens is that now you have this mass. I will take this 10 kilograms. Now this is an angle velocity. I can decompose this angle velocity into its horizontal and vertical components. This is 10 kilograms. In this direction it will be 8 cos 30, and in this direction it will be 8 sin 30. Right? 8 cos 30 in the horizontal direction and 8 sin 30 in the vertical direction. So if you are taking the 6 kilogram object, it has a horizontal velocity of 6 cos 60. So this is 6 cos 60. In this direction 6 cos 60, and in this direction it will be 6 sin 60. 6 sin 60. 6 sin 60. Alright, so if we decompose the velocity of the mass mass after collision, that is the mass that is going as a unit, the mass is added. So we can decompose like this. This is 16 kilograms. This is v cos theta, and this is v sin theta, right? V cos theta and v sin theta. So this is 16 kilograms. Now you have the momentum in two directions. One set of momentums in the horizontal direction and one set of momentums in the vertical direction. Now you can put the conservation of linear momentum, because the total external force on this system is 0. You can put conservation of linear momentum in both directions, horizontally and vertically, and find the value of V and theta. So I put conservation of linear momentum in horizontal direction. So I'll take this direction as positive, right? This direction as positive. So I can say that if the linear momentum in the horizontal direction in that direction is positive, I can say the initial velocity in that direction should be equal to the final velocity. Sorry, initial momentum in the direction should be equal to the final momentum in that direction. So Pi equals Pf, this direction, right? If Pi equals Pf, we can say that the momentum of this object in this direction, its mass is 10 kilograms and its velocity is 8 cos 30, so its momentum is 80 cos 30 in this direction. 80 cos 30 in this direction, 80 cos 30, and for this mass, its mass is 6 kilograms and its horizontal component is 6 cos 60, so its momentum will be 6 times 6 cos 60, which is 36 cos 60, and that is also in that direction. 36 cos 60 in this direction, and those additions is the only, we can find that is the only horizontal initial momentum on the system. So that should be equal to the final momentum of this system in horizontal direction. So the final momentum is when the two objects are combined each other and then they move as a single unit. So the single unit has a mass of 16 kilograms and its velocity is v cos theta, so that is also in that direction. So this is 16 v cos theta. In this direction, 16 v cos theta. Now all the velocities are in the same direction. Now we can add these two and make this as equation. So 80 cos 30, cos 30 cos 30 is equal to root 3 by 2. So 80 cos 30 will be equal to 40 root 3. So this is 40 root 3, right? Plus, because the other velocity is also in the same direction. 36 cos 60 is half, so 36 times half is 18. Is equal to 16 v cos 60, so we have taken the positive to be the velocity of that velocity of the composite, the final velocity of the final momentum, actually the final momentum of this composite also in the same direction, so we can say that it is positive. So this is 16 v cos 60. Sorry, 16 v cos theta, right? Cos theta. So this is equation number 1. So this is equation number 1. So we equalize the initial and the final momentums in horizontal direction, or we put the conservation of linear momentum for the system in the horizontal direction, or we can put the conservation of linear momentum in the vertical direction as well. So if we put vertical direction, in the vertical direction, Pi equals Pf in the vertical direction, you can say, right? Pi equals Pf in the vertical direction, you can say I'll take this arrow, the direction of this arrow is positive, so this direction is positive, right? So this direction is positive, upward direction, so the downward direction will be negative, so the momentum or the velocities in that direction, downward direction will be positive, and the momentum and the velocities in the upward direction will be positive. So the momentum of this object, the first object here, is in the downward direction, so the mass times the velocity is in the downward direction, so that will be negative. So that will be, the mass is 10 kilograms and the velocity is 8 sin 30, so that will be 10 times 8 sin 30, that will be 80 sin 30. Sin 30 is equal to half, so I will directly write, so 80 sin 30 is equal to 40, that will be in the downward direction. So this is downward, 40, right? Plus, I will take plus. So this object's mass is 6 kilograms and its velocity is 6 sin 60. So its momentum in that direction will be 6 times sin 60. So 6 times 6 is 36. 36 times sin 60 is 36 times root 3 by 2. So that is 18 root 3. So that is in that direction, upward direction. 18 root 3. Right? 18 root 3. So those are the only initial momentums of the system. So that should equal to final momentum. So that when you take in the final momentum, the system is going as a composite. So the mass of that is 16 kilograms and the velocity of that is v sine theta. So I have taken this sign as positive, so I will still take it. If it is negative, I can take that v is in the other direction. So the momentum, final momentum of the system is 16 v sine theta. So 40 downwards plus 18 root 3 upwards is equal to 16 v sine theta upwards. Now you know that 40 root 3 and 18 here, 40 root 3 and 18, so that's positive. So this direction will be positive. So v cos theta will be in this direction. So this is 18 root 3 in the positive direction and 40 in the other direction. So this will be 18 root 3 minus 40. In this direction, if you take, because you can, because they are vectors, you can change. So this is right. So since these are vectors, you can put a minus value and change the direction. So that is equal to 16 v sine theta in this direction. Right? So 18 root 3 is equal to 1.7. So 18 times 1.7 is equal to it is less than 40, right? It is less than 40. So 18 root 3 minus 40 will be the minus value. So v sine theta will be actually in the downward direction. So v sine theta is in the downward direction. So we can divide it by 16. So you can say v cos theta is equal to 40 root 3 plus 18 divided by 16, and v sine theta is equal to, so v cos theta is in this direction, right? V cos theta is in this direction because it is positive. V sine theta is in this direction because it is negative. V sine theta is equal to 18 root 3 minus 40 divided by 16. So we can find tan theta as in the last example. Tan theta is equal to v sine theta divided by v cos theta. So tan theta is equal to 16 to 16 cancel. 18 root 3 minus 40 divided by 18 plus 40 root 3. 18 root 3 minus 40 divided by 40 root 3 plus 18. Right? So that is tan theta. We want to find theta. So theta is equal to tan inverse of arctan of this. I will take tan inverse. 18 root 3 minus 40 divided by 40 root 3 plus 80. Right? So that is theta equals tan inverse. You can solve this and find the tan inverse value. Then you can find theta. So 18 root 3 minus 40 is negative, and 40 root 3 plus 18 is positive. So the numerator will be negative, denominator will be positive. So this one will be tan inverse minus something. So tan inverse minus something, you know that tan theta is minus. When tan theta is minus, it should be in this direction. So actually the angle here is not in the clockwise direction as we took. So the angle will be the same angle, but in not in the counterclockwise direction or anti-clockwise direction. The angle will be in the clockwise direction. So the angle will be somewhere here, in this direction, right? This direction. And if you take v is equal to square of this, square of v, as in the last example, v squared sine squared theta plus v squared cos squared theta. I did that, and then take the root. So you know that we can take that 40 root 3 plus 18 whole thing square plus 18 root 3 minus 40 whole thing square and root of that, plus or minus, right? So this is 40 root 3 square plus 18 root 3 square plus 18 square plus 40 square plus 2 times 18 times 40 root 3 minus 2 times 18 root 3 times 40. So this will cancel out. So this will be the positive value. So it should be a positive value, but v will be positive. So v will actually be if v is positive and theta is negative, this can't happen, right? This can't happen. So you have to take the negative root of that and take v in this direction. So v is negative, theta is negative. So we can find v from this and theta from this. So there's another example of the conservation of linear momentum. So in the next video I will talk about another concept of linear momentum, and thanks for watching this video and see you there.